Hello, everyone. My name is Daniel Sazin. I'm a rising third-year PhD student at Temple University's Cognitive Neuroscience program in David Smith's Neuroeconomics Lab, and I'm really excited to share with you some of our recent results looking into a meta-analysis of explore-exploit decisions. So to understand explore-exploit decisions, in these situations, we look at the trade-off between exploiting known resources versus exploring a unknown alternative. So for example, you can have n-armed bandit problems, which you can think of as a slot machine, where you can take an existing slot machine or move on to another one, or a foraging problem, where you have a given resource, a patch, a tree, or anything like this, which ultimately gets depleted over time, and then determining when you travel to another patch to go and exploit that other resource. And in either of these situations, you have an optimal kind of trade-off between when you do one versus another thing. But notably, there's no behavioral convergent validity between these tasks, meaning how one behaves with slot machines is not going to predict how you forage a given resource. And looking into this, and considering that there are quite a number of neuroimaging results that go and look at these respective tasks, we wondered if this discrepancy between these tasks is that if it has something to do with the brain. And so we wanted to assess if there's converging brain activity in between these given tasks. And to do so, we conducted a meta-analysis where we identified, screened, and included studies that conform to the search terms that we defined. And we only found about 14 studies, which we were a bit surprised. We thought there would be a bit more. Nonetheless, we included in our general studies these 14, and of them 9 were n-armed bandits and 5 of them were foraging problems. And we followed up through the analysis using SDM. We hypothesized that there would be convergence across explore-exploit studies in the ventral medial prefrontal cortex, dorsolateral prefrontal cortex, ventral striatum, anterior cingulate, and intraparietal sulcus. And in our results, and kind of our course results, where we just included everything, and we find predictably that there is activation in decision-making areas, including the dorsal anterior cingulate, cortex, anterior insula, intraparietal sulcus, and the amygdala. Notably, though, what was absent was the areas like the ventral medial and dorsolateral prefrontal cortex. When we delve into these results more deeply, when we look at the explore condition, we find that the dorsal anterior cingulate and anterior insula were notable and significant in how they converged. However, again, we did not find these kind of canonical executive areas. There were, when we followed up on the dorsal anterior cingulate cortex peak, we did not find any publication bias. And these two regions are notable in their as being prominent in the Salience network, and we thought that was a pretty interesting result. When we looked into the exploit results, we did not find any of the hypothesized regions were significant. However, the posterior cingulate cortex was. Now, in interpreting this result, we note first that these results were limited to n-armed bandits, as explore and exploit conditions were not reported in foraging studies. Secondly, only 5 studies reported exploit conditions specifically. So we take these results with a little bit of a grain of salt. Nonetheless, the convergence in the posterior cingulate cortex was interesting because this area is prominent in the default mode network in kind of regulating attention. And so we thought that was interesting on its own account. Ultimately, in our conclusions, we did not find the executive networks that featuring the ventral medial and dorsolateral prefrontal cortex were in our analysis, which we thought was interesting. However, the Salience network, particularly in the explore condition, was featured prominently, and we thought this one might help distinguish future explore-exploit studies in an interesting way. Some kind of analyses that we hope to do, such as comparing n-armed bandits and foraging studies, or doing kind of convergence or conjunction analysis between explore and exploit conditions, we were unable to do as we had too few studies to do so. And as more studies come out, we would very much hope to follow up on that, on those analyses. However, in conclusion, we do think that the convergence in the Salience network and the explorer condition was interesting, and it's worth following up on that in the future. Thank you very much for tuning in, and we hope you enjoyed it, and and have a wonderful day.